Everyone, welcome back. Today we will be studying something interesting about integrations. We will be studying about Fulani's integral, right? Uh, First, let us get ourselves in hang with Fulani's integral form, which goes like this: f(ax) minus f(bx) by x dx. This is equals to ln b by a, right? If you want its derivation, we can make a separate video on it, but today we'll be going to look at its some of its applications in our JEE syllabus, right? But this is obviously for advanced, right? Only for advanced. So let's see a question uh, regarding the wait a minute regarding the Fulani's integral. Dx, right? So this is the question. Now how we are supposed to solve this using the Fulani's integral technique. So first we have to make same functions, right? uh, so what we have to do here, we have to take abx and we have to divide the whole numerator, right? If we divide abx to this term, it becomes sine ax by ax, and if we divide it by this term, this becomes sine bx by bx by x dx, right? Integration 0 to infinity, and this in fact becomes the Fulani's form, right? What was the Fulani's form? Fax ax minus fbx f of bx by x. In limits are also 0 to infinity. So this in fact is our Fulani's integral form, where fx is sine x by x, right? So this integral turns out to be f of 0 minus f of infinity l of b by a, right? Ln of b by a, and ln of b by a remains as it is. F of 0 means limit x tends to 0 sine x by x, as f of x is not defined, we have to take the limit here. And similarly for infinity also, x tends to infinity sine x by x. Now as sine x is a closed function, but x gives when, right? So when x tends to infinity, sine x is a bounded function and has a definite range of -1 to 1, but x becomes infinity though, so this term becomes 0. And we all know limit x tends to 0 sine x by x equals to 1. We can prove it by expansion also, right? And it is also a standard formula for limit, right? Standard result. So we can say that f of 0 is 1 and f of infinity is 0. So we can say that its answer turns out to be ln b by a, right? So this is our answer for this question, right? Now let's look at another question based on the Fulani's integral, and that is tan inverse ax minus tan inverse bx by x dx. Now here it is obviously pretty clear that fx is tan inverse x, right? Fx is tan inverse x. So Now fx is tan inverse x, and if we apply the Frullani's form, right, if we apply the Frullani's form, we can say that tan inverse of 0 minus tan inverse of infinity ln b by a, right? Now tan inverse of 0 is 0. What is tan inverse of infinity? We can say that for the principal range, if you draw the graph of tan x, infinity is achieved at pi by 2. So this is approximately equal to pi by 2. This gives us minus pi by 2 ln b by a. So we can write that tan inverse ax minus tan inverse bx by x is equals to minus pi by 2 ln b by a, right? Directly from Frullani's technique. Although we have a second method for it, Feynman's technique we can use here. If you want a video, we can do that also. Okay, now let's see one more. This is actually a good question. Well, not so good question within our JEE syllabus, and that too for extreme rankers, right? Under you can say 100 rankers or 500 rankers, they are required to know this technique. Otherwise most probably this will not end up in your exam, but for your coaching preparation, coaching exams like Allen and Fitji and Narayana, etc., they can give such type of integrals, right? If you guys want a series for integrals from the Putnam Olympiad, right, do let me know in the comments, right? Do let me know in the comments. I will sure bring up some more new exciting mathematical and creative content, right? So now we have made it till here. Now let's do one thing. For the Frullani's integral, let's divide this whole, right? Let me do it. Right, let me divide the whole thing bx, right? So this becomes by x 1 by e to the power bx plus 1 minus 1 by e to the power ax plus 1 dx. Now here you can see that Frullani's form exists, but here the ln will be a by b, as a is in the negative, right? Now what would be our fx? Clearly f bx is equals to 1 by e bx plus 1, f ax is equals to 1 by e ax plus 1. So fx is 1 by ex plus 1, right? So f of 0 is nothing but 1 by 2, and f of infinity, now e to the power of infinity tends to infinity, so this becomes 1 by infinity form, and that is 0, right? So this is 0 and this is 1 by 2, so this turns out to be 1 by 2 ln a by b, right? This is the answer using the Frullani's technique, right? Let's look at, I was going to give it first, but dx, right? This integration, so this integration is also directly Frullani's form, and fx is e to the power of minus x, right? So this integration, let's say it is a I, so this integration is nothing but f f of 0 minus f of infinity ln a by b, ln a by b, right? Right. uh, Sorry, it would be b by a, right? As b is in the negative portion here, so b would be at the top, right? Right. So let's see f of 0. F of 0 is 1, right? F of 0 is 1, right? Obviously e to the power minus 0 is 1, right? And f of infinity, now let's see, e to the power of minus infinity, that's will e to the power infinity, this tends to infinity, this is 1 by infinity, this tends to 0, right? So f of infinity is nothing but 0, so this is ln b by a, so that is ln b by a simply, right? Right. So this is the Frullani's form of integration. Let me give you a question for homework. Do tell me its answer in the comments, right? As pretty simple though, right? Same answer it would be, same answer it would be, right? The same answer it would be, right? So yeah, thanks for watching. Do subscribe and like the video. More exciting content soon. Thank you.